Find and plot two solutions to the equation y equals 3x. Draw a line between the points and find the slope of the line. Verify the slope would be the same if you selected two different points. To answer this question, I'm going to begin by selecting two solutions that I think would be easy to work with. So the first point I'm going to select is the point 0, 0. I know the point 0, 0 will be on my line because if I replace x in my equation y equals 3x with 0, then I get that y equals 3 times 0, which is in fact 0. So I have the point 0, 0. The second point, I'm going to replace x with the value 1. And I notice that if x is 1, y would be equal to 3 times 1, or 3. And so I'm going to find the point 1, 3. This height here will be 3. Let's draw the line between these points. There we go. And now let's try to compute the slope of this line. Well, because I selected 2 points where the distance between the 2 points is only 1 unit in the x direction, I can use my initial definition of slope to answer this question. So I know that slope can be the change in the y direction, how much we move up when we move 1 unit right. Therefore, to compute slope in this case, I can just say, reading off the graph, that the slope here is 3 because when I move 1 unit right on the graph, our y values increase by 3. Recall that anytime we're in a situation where the values increase as we move from left to the right, we get a positive slope. Now, I could also verify that this is the slope using my formula. My formula involving P1, P2, and R1, R2. In our example, our first point P would be the point 0, 0, and our second point R would be the point 1, 3. In this case, my slope looks like the y-coordinate of R minus the y-coordinate of P, so 3 minus 0, all divided by, I'm going to put parentheses to remind us to do our subtraction first, the x-coordinate of the point R, which is 1, minus the x-coordinate of the point P, which is 0. And in this case, we get 3 minus 0, which is 3, divided by 1 minus 0, which is 1, a ratio of 3 to 1, which is 3. And in that way, we're seeing that the ratio of that rise over that run also can be used to get this answer. So at this point, we have found and plotted the two solutions, we've drawn a line, and we've computed the slope of that line. The question is, would it have been the same if I selected two different points? Well, to start that process, I'm going to keep one of the points the same. I'm going to let us keep the point 0, 0, and I'm going to select a different second point, and I'm going to give it coordinates x, y, because it's an unknown x and an unknown y, and I'm going to name it point R. We're going to name our original point P, and I'm going to rename the 1, 3 that we used before A. Now, when we found slope in the past, we frequently needed some similar triangles in order to do this work, so I'm going to drop a vertical as well. And notice that the coordinates of the point where the vertical line through R hits the x-axis will be x, 0, where that's the same x that I see in my point R. So I would like to see that the rise over run using points P and R is the same as for the points P and A, and in particular that we still get that value will be 3. To do that, I'm going to use some similar triangles. I have one small triangle and then I have a bigger triangle. And I have my points A, B, R, Q, and P. I claim these two triangles are similar by angle, angle. Tell me why. Give me an angle that is common to both triangles. Share it in the chat. Yes, just like last time, we saw that the angle formed ABPB or RPQ, if you will, that angle's common. So we have by angle, angle, since angle A, and what's another angle they both have in common? Yeah, we have two parallel lines, parallel line 1, parallel line 2, those verticals, and they're both intersecting with the x-axis. And that way they both form right angles. PBA and angle BQR have same measure. So since we know that these two triangles are in fact similar, we can set up equivalent proportions to common sides. So I know that the length of RQ, its ratio to the length of AB, should be equal to the length of PQ divided by the length of PB. Let's look back at the coordinates in our picture to find out what the lengths of each of these sides are. The length of PQ, oh, well that's going to be x because P is at 0, 0, and so going all the way to x, 0, going to that x coordinate, that's x. So on top here we have an x. Additionally, PB we know is 1. On the other side, we have RQ. RQ is the height of the taller triangle. Its height goes all the way up to the y coordinate at the point R, so its height is y, divided by, what's the height of the smaller triangle? Oh, well, that's the slope. That's that 3. So we have y divided by 3 equals x divided by 1. From this formula, we obtain, by cross multiplying, that y equals 3x. Now, if y equals 3x, then what is the ratio of y to x? Notice the ratio of y to x is 3, and that would have represented the slope of my line. So we've established that the slope of the line between any 2 points will in fact be the number that is the coefficient on x. So the slope of the line through any 2 points of the equation y equals mx is the number m.